Something massive is entering our solar system, and it's not from around here. Detected just weeks ago, a 33 billion ton object now labeled 3I Atlas is racing through space at over 26 kilometers per second.
I'm tracking its trajectory
It's 3
now.
to 5 kilometers wide, larger than any known interstellar visitor to date. And for the first time in history, the United Nations has fast-tracked an emergency space policy meeting. Why? Because every major space agency on Earth, NASA, ESA, JAXA, and even planetary probes around Mars and Jupiter, has suddenly turned their eyes to this one object. This isn't another Oumuamua, the strange cigar-shaped anomaly that vanished before we could even get a clear photo. And it's not like Borisov, the icy comet-like visitor of 2019 that matched our expectations. 3I Atlas breaks the mold. The first images revealed a nucleus wrapped in a teardrop dust shell, comet-like, yet its chemistry tells a different story. When James Webb locked onto it, the infrared data returned an unprecedented signature, a massive overload of carbon dioxide, over 8 times more than water, a ratio virtually unheard of in comets from our solar system. This, combined with a total lack of expected acceleration from outgassing, has stunned researchers. Normally, sublimating gases would create thrust, subtly altering a comet's path, but this one glides forward with unnerving stability, almost like it's on invisible rails. The orbit hyperbolic. In plain terms, it's not bound to our sun. It came from deep space and will leave again fast. That means no do-overs, no second chances. The object will reach its closest point to the sun, called perihelion, on October 30th, 2025, passing just inside Mars's orbit. After that, it slingshots back out, never to return. So here's the urgent question. Now rippling through observatories and space command centers, is humanity ready to respond to something that comes from beyond our planetary neighborhood? Something we cannot predict, cannot intercept in time, and barely understand. As cameras across the solar system lock on, scientists and policymakers are waking up to a sobering truth. Our entire planetary defense infrastructure was built for familiar threats. Asteroids, near-Earth objects, icy bodies we've cataloged for decades. But 3I Atlas is rewriting the rules. There is no global plan for fast-moving interstellar objects, no treaty, no shared mission protocol. And that vacuum is now center stage, not just in science labs, but in diplomatic rooms in Vienna, where the UN Space Committee is scrambling to draft what could become the world's first interstellar response framework. Could this be a turning point, or will it reveal just how unprepared we are when the unknown knocks? One thing is clear. This is not just a comet. It's a warning. The data surrounding 3I Atlas is not just unusual, it's unprecedented. From the moment the Atlas Survey Telescope in Chile flagged its trajectory on July 1st, the object defied expectations. Recovery images traced it back to mid-June, confirming its hyperbolic path. By July 21st, NASA's Hubble had captured detailed visuals, a solid, stable nucleus, trailing a faint tail, the kind of signature typical of a comet. But the devil was in the details. When the James Webb Space Telescope turned its infrared spectrometer on the object on August 6th, the readings flipped every expectation. Instead of water ice being the dominant component, as in most comets, the object's composition was saturated with carbon dioxide. Water was barely detectable. More bizarrely, the spectral analysis revealed trace amounts of atomic nickel, a metal that under cosmic conditions usually appears alongside iron. But here, no iron, just nickel isolated. This anomaly in elemental bonding patterns suggests a chemical origin completely alien to any known formation process in our solar system. These are not minor variations. They're compositional fingerprints, and they hint at origins beyond anything we've cataloged, perhaps from the far-flung equivalent of another system's Kuiper belt, or even further, where solar influence is a distant whisper. What's more, the expected outgassing behavior simply isn't there. For a body of this size, 3 to 5 kilometers wide, the sublimation of volatile ices should produce measurable thrust, subtly nudging the trajectory over time. But 3I Atlas has shown virtually no non-gravitational acceleration. This eerie glide, smooth, consistent, and untouched by typical cometary physics, has raised eyebrows even among the most conservative researchers. This isn't how comets behave, at least not ours. And that's precisely what's triggered the global scramble. The European Space Agency, still finalizing its Comet Interceptor mission, is rushing to simulate whether a launch could still be possible. NASA, too, has conceptual interstellar probes on the drawing board, fast Delta-V heavy spacecraft designed for deep space interception. But these plans were theoretical. 3I Atlas just made them urgent. ESA's Mars Express and ExoMars Trace gas orbiter are now reprogrammed to capture images during the object's close Mars flyby on October 3, 2025. Juice. The Jupiter Icy Moons Explorer is positioned to track the object through November from a different vantage point. Even rovers like Curiosity and Perseverance, designed to study Martian soil, have been tasked with skyward calibration images to contribute to the growing data pool. The objective is clear: seize every moment before the window closes. The sheer weight and speed of this object mean that once it swings past perihelion, we lose it. Forever. No telescope will follow it past Jupiter's glare. No mission will catch it. And so every camera, every sensor, every telescope is now part of a global symphony of observation, all trained on a single silent visitor from the stars. As the global network of telescopes tightens its focus on 3I Atlas, the event is no longer being treated as a scientific anomaly. It's becoming a policy stress test. Internal memos across agencies no longer refer to it as a comet. The language has shifted: ISO interstellar object. That single designation changes the entire framework, because when something isn't bound to our sun, it also isn't bound to our existing response models. That's where the United Nations Committee on the Peaceful Uses of Outer Space, COPUOS, enters the scene. Normally a slow-moving body dealing with long-term treaties and regulatory frameworks, COPUOS has now elevated the 3I Atlas session to the top of its agenda. Because this object is exposing every crack in our global readiness. What happens if the next ISO shows signs of acceleration that can't be explained by physics alone? What if it emits signals? What if it changes course? These aren't science fiction questions anymore. They're logistical nightmares. Right now, there's no international protocol requiring data sharing on fast-moving deep space objects. If a private company were to detect one first, say, a SpaceX telescope or a Chinese orbital array, they wouldn't be legally required to tell anyone. Worse still, if two nations proposed conflicting missions, there's no arbitration process, no lead agency, no unified mission command, just a race against physics. That's why Harvard astrophysicist Avi Loeb and his team proposed a new body, the United Nations Committee on Interstellar Objects, UNCO. The proposal includes a classification framework, the LOE scale level of extraterrestrial likelihood, ranking from 0 ordinary comet to 10 confirmed artificial origin. It doesn't claim alien contact. It provides a language for coordination, a way to escalate or de-escalate global responses without panic or chaos. The scale is already in informal use among researchers handling 3I Atlas, which would likely rank around LOE 4 or 5 unusual, but still natural. Still, even that score demands international eyes. Consider the implications. What we're witnessing is the first coordinated multi-planet observatory campaign ever aimed at a single interstellar object. Ground-based telescopes in Chile, Hawaii, and Australia. Space-based assets like Webb Hubble TESS. Planetary orbiters around Mars and Jupiter. Even rovers designed to dig Martian soil are looking up. The magnitude of this coordination is staggering. These systems were never built to work together. Different countries, different formats, different goals. But for the first time, they're feeding data into shared archives, forming a distributed sensor web across the solar system. And behind the scenes, debates are intensifying. Some policymakers want to create early warning treaties, requiring member states to share data on any new hyperbolic detections within 24 hours. Others push for legal guidelines around commercial missions. If a private firm intercepts an ISO and discovers rare isotopes or exotic ices, who owns it? Who regulates it? What if that data holds secrets about planetary formation, or even life-space law today is vague, a patchwork of Cold War-era agreements and ad hoc arrangements? 3i Atlas just dragged it all into the spotlight. It's not about this object being artificial. It's about this object revealing how unprepared we are for something that might be. And the fact that Earth's first real rehearsal is being rushed through policy meetings in Vienna should give everyone pause. Because next time, we might not have 4 months to react. We might have 4 days, or 4 hours. So here we are watching calculating coordinating as a frozen relic from beyond our solar system, cut silently across the night sky. And despite the data, the models, and the missions, the most pressing question still lingers. What is 3i Atlas really telling us? On paper, it's natural. Everything we've observed, from its mass and speed to its faint outgassing and exotic chemistry, fits within the realm of possibility. Strange, yes, but explainable. Yet no one denies that this is different. Its sheer size alone, 33 billion tons, makes it the most massive interstellar object we've ever recorded. Its pristine composition, untouched by close stellar passes, offers an unfiltered look into the building blocks of distant planetary systems. It's like holding a piece of another sun's nursery in our hands. But hands we don't have. We're watching it slip away, unable to catch it, to sample it, to touch it. Unless a mission is launched within the next 2 years, a feat requiring immediate funding, political alignment, and perfect engineering, 3i Atlas will be gone forever. And with it, the chance to physically study material from beyond the solar system. Scientists know this. So do space agencies. And so does the private sector. SpaceX, Rocket Lab, Blue Origin, the players who can build and launch within months, not years, are now part of the equation. But that raises a dangerous new layer if interstellar objects become targets of economic or strategic value. Who controls the race? Who owns material from another star? Can corporations legally intercept, mine, or retrieve cosmic matter without global oversight? Or will space become the next frontier of geopolitical tension? These questions are no longer philosophical. 3i Atlas has transformed them into legal and logistical time bombs. At the same time, AI is becoming a key player. NASA's Sentry-2, originally trained to forecast asteroid impacts, is now being reprogrammed to predict hyperbolic paths in real time. One day soon, machine learning might spot the next interstellar object and recommend a probe's trajectory within minutes. But that technological promise also highlights the urgency of what we lack: treaties, trust, readiness. Because here's the reality: interstellar objects are not once-in-a-century events. They've always been passing through. We just weren't looking. Better AI, better telescopes, and better global coordination have finally allowed us to see them. And the systems we build, now how we track, respond, share, and act, will define whether we're ready for what comes next. Today, it's 3i Atlas. Silent, natural, magnificent. But what if the next one isn't so quiet? What if it's faster, more volatile, or designed? When the unknown knocks again, who answers? Who speaks for Earth?